I can't really pick one favorite scientist. Okay, right here. Nikola Tesla, Albert Einstein, Niels Bohr, and Isaac Newton. Done.
A child once hailed as the world's smartest kid disappeared without a trace, sparking widespread mystery and fear. Years of silence followed, leaving everyone to wonder if he would ever be found. What could he possibly have learned that's so urgent and frightening? Join us to uncover the startling truth behind his message, the genius behind the free energy device. Max Laughlin was known around the world as the brightest young mind. He amazed everyone with his deep understanding of science and technology. He became famous for his fresh ideas about CERN and his invention of a device that could generate free energy. However, Max's life took a surprising turn when he suddenly vanished, leaving people to wonder where he had gone and what he was doing. After being gone for a while, Max came back, but his return only brought more questions. Some thought he had been doing secret research in unknown places, while others believed he might have been taken by people who wanted to use his genius for their own gain. Some even thought the pressures of fame were too much for him. With little information available, many theories spread about his disappearance and activities. Max's journey began with a strong interest in science, technology, and physics. From a young age, he understood complex scientific ideas better than other kids his age. He made big contributions, like designing a machine that could generate free energy, which impressed the scientific community. Max also had theories linking the Mandela effect to CERN's activities, which added to his impressive reputation. His love for understanding how things worked was clear even in elementary school. He was fascinated by renewable energy and space mysteries. This passion grew as he moved through school, leading to great achievements in high school. In his senior year, Max worked on a project with his friend Luke Janssen, using photogrammetry to create 3D models of ancient rock carvings in the Valley of Fire State Park. Despite technical challenges, Max's determination and independent thinking shone through. Max dreamed of digitally preserving ancient rock carvings worldwide, blending his love for science, art, and history. His interest in physics and engineering guided him through high school and into college. His dedication and talent earned him a spot at the prestigious University of Wisconsin-Madison, a big step in his academic and professional growth. He wanted to lead in scientific innovation, using his deep knowledge to make big contributions to the global scientific community. His time at the University of Wisconsin-Madison gave him chances to further his studies and innovations in physics and engineering. Before college, Max went on a journey of exploration, diving deep into particle physics and renewable energy. His early career focused on understanding and using the fundamental forces of the universe. His quest to discover new types of energy was part of his broader goal to unlock the universe's potential. His inventions aimed at more than just technological improvements. They imagined a future where renewable energy could change our world. These efforts caught the attention of both the scientific community and the energy industry, marking him as a promising figure ready to transform the field. Max's early career was marked by a strong desire to explore and contribute to the understanding of the physical world. Max Laughlin's love for renewable energy and his groundbreaking free energy device made him a key player in the push for sustainable power. His creative solutions tackled tough energy problems, offering real alternatives to traditional energy sources. Even at a young age, his impact was huge, challenging old energy ideas and opening new doors for sustainable energy. His ideas not only changed how we think about energy, but also broadened the ways we can use renewable resources. Max's drive to tap into nature's power was more than just a career goal. It was a personal mission to create a more balanced and sustainable world for future generations. His hands-on approach to using his vast knowledge put him at a critical point where science meets industry, sparking big changes. But then something unexpected happened. Max suddenly vanished. This shocking event sent waves through the scientific world, leading to a lot of questions and speculation. Where did Max go? Why did he disappear so suddenly? The impact of his absence was deeply felt, especially among scientists where he was a major figure. The projects he led were left in limbo, causing confusion among his colleagues and friends. The strange circumstances of his disappearance fueled endless discussions and added more mystery to his story. When Max finally returned, everyone felt relieved, but there was also a burning curiosity about what happened during his time away. His return answered some questions, but also brought new mysteries into his already fascinating story. Among Max's many achievements, his creation of a free energy machine stood out as a powerful symbol of hope and innovation. This device wasn't just a scientific breakthrough, it represented the big dreams of both the scientific community and the general public. His comeback and invention sparked new excitement and hope, highlighting the machine's potential as a bright light for a sustainable and efficient future. This project went beyond local or academic interests, embracing a global vision. His influence went beyond just technical achievements. Like Malala Yousafzai and Elizabeth Nance, Max showed that young people could make a big impact, with their ideas reaching the whole world. He became famous for his deep insights into universal forces and human adaptability, actively engaging with the big issues facing humanity. His worries even extended to the work at CERN, especially the Large Hadron Collider. Through videos and public statements, Max voiced his concerns about the experiments there, suggesting they could have significant effects on our reality. These weren't just informational videos, they were warnings that sparked discussions among experts and the public alike. Max's research suggested that the experiments might mess with the very fabric of our universe, possibly shifting us into a parallel reality without us knowing. He explored the idea of the multiverse, proposing that many unseen parallel worlds exist alongside our own. According to Max, the events at CERN started normally, but then took an unexpected turn, hinting at unknown consequences that could reach far beyond the scientific community. Max's bold ideas and warnings continued to resonate, pushing people to think deeply about the impact of scientific experiments on our reality. His journey, filled with breakthroughs and mysteries, continues to inspire and provoke thought, making Max Laughlin a name to remember in the world of science and innovation. As we turn the page, Max's next chapter awaits, promising further revelations and deeper mysteries. Exploring parallel universes. Max Laughlin has shared some interesting thoughts about the Large Hadron Collider, LHC. He believes that it might have shifted our reality into one of many parallel universes. According to him, the experiments at CERN could have even changed historical events. These ideas challenge our traditional views of reality and suggest that other universes might be close to ours. Max thinks that the LHC, which is a particle accelerator, could have changed a single electron. This change might have fractured our reality and pushed us into a new universe. His idea has sparked both interest and concern, leading to many debates and further research in the scientific community. Some critics say his ideas lack solid proof and are too speculative. Despite this, his bold statements keep the discussions and research going, showing the importance of questioning what we think we know about reality. The LHC is a monumental scientific achievement that has facilitated numerous significant discoveries, including the Higgs boson. This particle was predicted by British physicist Peter Higgs in the 1960s and is essential for understanding how some particles acquire mass. The Higgs boson interacts with a field reminiscent of a thick, syrupy substance. As particles move through this field, it slows them down, similar to walking through water, thus giving them mass. The collider achieves this by smashing protons at very high speeds. These collisions disturb the Higgs field and enable scientists to observe the Higgs boson. Uncovering this particle has deepened our understanding of a fundamental aspect of the universe, illustrating that space is not empty, but filled with this field, suggesting it has a background energy. Recently, scientists found X particles in the quark-gluon plasma created by the collider. These particles give us a glimpse back to just a few millionths of a second after the Big Bang, when the universe was mostly a hot plasma soup. This discovery could help us understand more about the origins of the universe. In light of these scientific advancements, the idea that our actions on Earth could have effects beyond our planet is fascinating. It adds an intriguing dimension to how we think about the connection between small and large aspects of the universe. The work done at the LHC could have profound implications, changing our basic understanding of the universe and our place in it. The recent discovery of X-particles, made up of quarks and gluons, has given scientists new ways to understand the early universe. They are trying to recreate this discovery using lead atoms with positive charges. These atoms are sped up and smashed together, creating a burst of plasma similar to the early universe's environment. This collision not only makes a bright flash of plasma, but also releases more particles, giving a detailed view of the high-energy conditions from the universe's early days. This new understanding is very important for our knowledge of the universe. But finding these X-particles is not easy. Scientists have to sort through billions of ion collisions, a tough job even for the Advanced Large Hadron Collider, LHC, at CERN, which will run until 2025 after a 2-year upgrade. CERN's goals go beyond just observing. They also want to explore dark matter, which makes up most of the universe's mass. However, some people think this expensive research may not be worth it. Theoretical physicist Sabine Hossenfelder suggests other projects, like putting a radio telescope on the moon or a gravitational wave detector in space, might give us more valuable results than costly collider experiments. This isn't the most controversial part. Max Laughlin's ideas, along with CERN's work, make us rethink our understanding of the universe. The experiments at the LHC not only challenge what we know, but also make us wonder what other discoveries are out there in particle physics. A big mystery today is what dark matter is made of, believed to be about 27% of the universe. The LHC has made important discoveries like proving the Higgs boson exists, but its success in studying dark matter is still debated. As the collider prepares for more runs, there are more discussions about its potential findings and what they mean for our understanding of the universe. Even with these debates and the important discoveries, some scientists think there might be better, cheaper ways to do research, like space observatories. The conversation among physicists continues as they look at different methods to answer fundamental questions in their field. Since the LHC started in 1988 near Geneva, some people have been afraid it could create black holes. Martin Rees and others worried that high-speed proton collisions might make tiny quantum black holes. Stephen Hawking said the collider didn't have enough energy to do that, but the debate goes on. Recent rumors about a possible quantum black hole near Geneva have started new discussions about the chance of such an event changing our planet, though scientists say this is very unlikely. With each experiment, the LHC not only looks deeper into the universe, but also makes us face big questions about the nature of our universe and the truths we might find as we keep exploring. In 2022, scientists noticed something strange happening with the Earth's magnetic field during a regular operation at the Large Hadron Collider. At first, they thought it was due to solar activity because of the intensity and timing. But after more investigation, they found out the disturbance happened exactly when a high-energy collision was conducted at the LHC, suggesting that the experiment itself could be the cause. This finding led to intense discussions among scientists about the safety of such high-energy experiments. They worried that these experiments might not only create tiny black holes, but also cause other unexpected phenomena with serious consequences. Researchers dug deeper and discovered that the collision could have broader effects on both the Earth's magnetic field and the overall cosmic environment. What lies ahead in our scientific journey might just blur the lines between fiction and reality. Magnetic field disruption. This event prompted a thorough review of CERN's safety protocols and the risks of particle collisions. Even though the exact cause of the magnetic field disruption is still being investigated, this incident highlighted the need for careful evaluation of the impacts of experimental physics on Earth. Further exploration raised questions about potential global problems like satellite malfunctions, power grid disruptions, and communication breakdowns. To understand these risks better, CERN scientists and other experts analyzed data from the collider and the environmental conditions during the disruption. They were especially focused on whether the LHC's collisions could create rare particles or trigger events that might temporarily affect the Earth's magnetic field. Despite the Standard Model offering a basic understanding, these inquiries introduced various theories and concerns within the scientific community, sparking a wider debate on the ethics of conducting large-scale scientific experiments. This led to important discussions on balancing the pursuit of scientific knowledge with the need to protect the environment. The incident at CERN became a key case study in assessing the dangers of pushing the boundaries of human understanding. The findings influenced how CERN would conduct future operations, including better monitoring systems around the LHC to study its interaction with the Earth's magnetic field. This scenario showed the need for strict safety measures and continual evaluations in particle physics. It also emphasized the importance of making sure scientific advancements do not harm the environment. The idea that a man-made structure could accidentally change our reality made scientists rethink traditional scientific perspectives and theories. But it gets even more intriguing. Among the theories sparked by such incidents is Max Laughlin's idea that particle accelerators like the LHC could change fundamental particles, possibly shifting our universe into a new dimension. Max suggests this might explain why some people remember events differently from recorded history, similar to the Mandela effect. Although some critics dismiss these ideas as mere speculation without proof, Max's propositions have stirred significant interest and debate within scientific circles about the nature of reality and the possibility of interdimensional travel. This ongoing dialogue highlights the importance of challenging our current understanding of the universe and considering the profound complexities that advanced physics brings to light. In the world of particle physics, the idea of interactions across different universes is really interesting. It makes us wonder, could our sometimes fuzzy memories be caused by such complex interactions? Let's talk about CERN, the European Organization for Nuclear Research. They are dealing with big energy shortages made worse by the conflict in Ukraine. This crisis has affected energy supplies all over Europe, impacting homes, businesses, and places like CERN. CERN needs as much power as a small city to run its experiments. The Large Hadron Collider, their most powerful experiment, uses about half of CERN's energy. To handle this, they scale down operations during the colder months to reduce the strain on the electrical grid. These limitations bring up worries about delays in important experiments and discoveries. CERN is working hard to cut down its power use, but there's a real chance that some activities might have to stop due to these shortages. This could impact not just the LHC but other experiments too, even those that already use energy-saving techniques. Despite these efforts, necessary measures could still cause delays. But even with these challenges, the scientists at CERN stay committed and hopeful, aiming to gather a lot of data by 2025. Now, the idea of a multiverse has fascinated scientists for a long time, way beyond its fun use in movies and TV shows. In science, especially in cosmology and quantum physics, it's a useful way to explain certain things in our universe. One theory in cosmology suggests that there are far-off areas within our universe with different physical laws. Quantum physics offers another view, called the many worlds interpretation, which suggests that every possible outcome of a quantum event happens in its own universe. For example, a quantum particle like an electron might spin in opposite directions at the same time, each spin happening in a different parallel universe. Physicist Sean Carroll explains that human decisions don't create new universes. Instead, these alternate realities come from quantum events, separate from our actions. This idea makes our existence in the multiverse like the relationship between identical twins, having similar pasts but unique futures. The multiverse not only stirs up deep psychological and philosophical debates, but also helps us understand actions and consequences, grounding us in a reality where our choices matter. The exploration of these theories at CERN shows its huge impact on science and public thought, reminding us of the need for humility in our quest for knowledge. CERN keeps pushing the boundaries of particle physics, constantly improving the LHC to study unusual phenomena and particles like neutrinos, which are crucial for understanding the universe. This groundbreaking research not only advances our knowledge, but also deepens our fascination with the complexities of the cosmos. The theories proposed by Max Laughlin and CERN's discoveries invite us to think about the universe's vastness and its intricate possibilities. Did his disappearance and return shed light on concerns we should have about tampering with the very fabric of our reality? What are the ethical limits of scientific experimentation? Share your thoughts in the comments below. Remember to like and subscribe for more.